one that we did yesterday, there are no more quizzes or tests until the final.
Oh.
But there are 3 new sections. Wait, I said there are 6 in Chapter 5. Yeah, we're not taking Chapter 5 tests until after break. There are only 3 that we need to get through before break. The fundamental, the foundation, and then the 2 different types of problems that will show up for the rest of the chapter. 5.1 uses the idea of given and prove. Ooh. Those types of problems that we didn't have on the test, but they kind of showed up just a little bit in homework. 5.2 says, let's make it formal and call it a T-proof. Actually, it says verifying identities, but whatever. And then 5.3 says, let's talk about inverse trig and how that gets helpful too. So chapter 5, 5.1, 5.2, 5.3, that's our goal. And once we hit 5.3, then we can say, let's final review it till the end. So 5.1, the foundation today. Homework. Oh, I don't think I wrote it up on the board. Sorry, still chapter 4 test. Due tomorrow. It's okay. I think it already popped up in Google Classroom this morning, didn't it? Oh, maybe I didn't schedule it yet. Do you guys remember how we can maybe rearrange things? So maybe all of these formulas that are actual formulas, yes, that's true, how they can show up different ways or be used different ways? Just in case you're still writing down formulas, let me go ahead and dual page it. But, boop, boop. If I was, oh, it's all frozen, so you're not seeing anything that I'm showing. All right, awkward. There you go.
Oh, yeah.
Pythagorean identities, and actually all of the identities, but these are the ones that we're going to use the most. All of the identities can be rearranged. Meaning, if you were to see a sine squared, you could say that you are sine times sine, but normally that's not going to help us with our puzzles. Because you're just restating what the shortcut notation is saying. Sometimes it might be helpful, usually it won't be. That's one way of saying sine squared. It's sine times sine. Okay, good. When I say sine, I mean it's an implied sine of its argument, sine of x, because sine without an argument is sin. That's bad. Sine squared of x is sine of x times sine of x. But what's another way of writing it? Check it. Where did I get that from?
From the Pythagorean entities.
Uh-huh. And why am I writing x's? Well, because that was an x. I'm not going to write a u. It doesn't make sense. Whatever's here is going to be there according to my identities. So u can be substituted in for. You can think, who are you? Hey, that's a good question, but actually it's who is you. In this context, it's not y-o-u. Okay, so what would be another way of writing cosine squared of x? What's another way of writing cosine squared of x? Cosine times cosine, yeah, we can do that. Or 1 minus
Sine squared.
Sine squared of x, because we could subtract sine squared to this side. Bianca, go ahead.
If you can do this with the Pythagorean identities, can you also rearrange the quotient?
Which means that sine of u could be cosine of u times tangent of u, but to be honest, we don't see that enough to like memorize it. These ones, though, we see it enough that we're going to want to have them like on top of our notes. Tangent times tangent or cotangent times cotangent, that's just rewriting. But with the Pythagoreans, we can say, oh, well, you're... Careful. Look at the Pythagorean for this guy. Tangent squared of x.
It has a, wait, it's got a secant.
Do the actual little rearrangement, solving for tangent squared. Caitlin's saying it. It's minus 1. It's a little bit different, right? But do you see? I mean, yes, it's a memorizing, but yes, it's also a, I know this formula. I can just move stuff around. How about cotangent squared of x?
Cosine.
Minus 1. You see it? We're just rearranging. And once again, exactly like Priyanka just said, we could rearrange all of these guys. Multiply stuff up and even subtract stuff over and do all sorts of awkward things. But this is kind of like the most natural and most commonly used rearrangement that we need to be ready with, kind of. Ready with in our toolbox to be able to use. these first problems that you're going to see should kind of remind you of section, or I should say chapter 4. Section 2, was that it?
I'm getting PTSD.
Except something is very different that's going to make this homework easy and hard all at the same time. Can you guys go back? Was it section 4.2 where this table showed up? Can you flip back real fast and find it for me and find the types of problems that we did? It was those given and proved ones. Oh, not 4.2, sorry, it was later. 4.3. 4.3. We did all the tables and all the formulas. And then we did little formulas, or sorry, little problems. And what were the directions? Did you write it down? Use identities to prove. Something like that, except look at the types of problems. What's different? Every single one of the problems we did with like a little t. Maybe there were thetas, but what else? They always had equals. What do these not have? They're not telling you what you're supposed to make it look like. They're just saying, oh, change it up. Well, okay, wait. They were very specific in these directions. They didn't just say change it up. They said factor and then simplify. Just a hint. Simplify is always a part of the directions for these. But they're giving you a hint. They're saying factor. Why are they saying factor? Do you guys see a minus?
The squares.
You see a minus? Minus. It's like a binomial. Okay, it's not. It's not a polynomial. I mean, it has tangents in it. It's like some sort of weird trig thing. But it's like a binomial where it has one big old lump on this side and one big old lump on that side. It's like a term and a term, just with trig in it. Is there something in common?
Yes, you can take a sine squared of all of them.
No.
What can you pull out?
Tan squared.
But don't just take out a tan squared. It means nothing until you also put the x.
Wait, why can't we get a sine squared?
This one doesn't have one.
But like, isn't tan like sine over cosine?
Okay, well, if we were to rewrite this sine squared over cosine squared and sine squared over cosine squared, we could have taken out a sine squared of x, but why not just take that over cosine squared of x also? Does that make sense? Now I see it, Alec. Yeah, you're right. They both have a sine squared in the tangent squared. My brain automatically was like, no, they don't, because I was looking at this one, not the inside. So yeah, you're right. They do have a sine squared over cosine squared, just took it all out. And simplify. Oh, sorry. Remember factoring? Whenever you factor, in case you're getting a little bit lost on that step, whenever you factor, you're trying to ask yourself what's in common. You take that out, but to take it out, remember we have to divide, because factoring is dividing. It's the opposite of multiplying. And so, what was left? A 1 minus a sine squared. You see it? And so once I pulled out that tangent squared, I'm actually using green for a very specific, much in the future and not exactly right now reason. I'm just going to make this red. Christmas! That's not really why, but that's okay. What can I make this because of what we just wrote down?
Cosine.
What's easier, a 1 and a minus and a trig, or just a trig?
Just a trig.
Got it. What's easier, multiplication and subtraction, or just multiplication? All right, you're done, and you would check the odd in the back of the book and be wrong. Well, are you wrong? You factored and you simplified. It's enough. That's the struggle. Because there is no equals and there is no other side, you're not exactly sure how far they want you to go. How far they want you to go. You can go farther. Alec, use what you were thinking about who tangent is to tell me what to do next.
You can make it sine over cosine. You just can't do cosines.
Just be careful that you're being precise with how you're writing it. But yes, the idea is right. Because if that's not a fraction, isn't it an understood over 1? Don't I have a cosine squared over a cosine squared, which is legal to reduce? Check it. This big old nasty thing ends up being who or what? Now, could you make sine squared 1 minus cosine squared of x? Sure. Opposite over hypotenuse of some random x squared? Sure, but would either of those be a simpler way of writing it? So we tend to let them stop. Send them out.
I should understand where you got the 1 minus sine squared.
Oh, let me talk that out as I get everybody else started on factoring and simplifying this one. Okay. But you saw the tan squared of x in common, right?
Yeah.
Okay. So imagine this. Relating that to something else. What if I was to give you something like x squared minus x squared y squared? And you were factoring.
Okay.
Super similar. But when you factor out an x squared, remember, factoring out is technically division.
Okay.
You see it?
Yeah.
It just looks nastier when you have all the trig stuff.
Yeah, makes sense.
So it's a long minus. We're having fun.
KJ, bro.
Tell me what's a factor, and then yes, you'll earn it.
KJ, man.
Oh, do you have it ready for me?
No.
Okay.
But I have to go to the bathroom.
Can I give him a hint? A squared minus b squared. Factors to become 1. Like when? Reach out to Emily. No. You reach out. Use your words. You're the one who has to go to the bathroom.
I'm pretty sure, don't you take the cosine 2x?
Oh, we're doing this now? Do you mean cosine squared of x?
Yeah.
Okay. You do something with it.
Don't you
I can make it a cosine times a cosine. I'm not sure it's going to help. I need to factor it, like with parentheses, like good old fashioned algebra.
Everyone is dying. She's dying.
How would you factor that one? How do we use it for this?
do like that?
So Emily's ready if you ask her for help. She might give you a clue.
And then you know.
Yeah.
So then use your words. All you have so far is that she knows.
KJ, don't be shy.
How did the answer explain it? How do I explain it?
Difference is squared.
Oh, difference is squared. You do the table is like you split it up, so it's like x plus 1, x minus 1.
Or x plus 2, x minus 2.
Yeah. And so you split up the square, so it's cosine plus 2 and cosine minus 2.
But KJ, is she right literally what she just said? Or is there something else that technically we need to put in?
There needs to be an X.
Yeah. Alright, now you can go. So we're done, right?
Yes.
Wait, but what was the point? As you leave, check it out. Yeah! Because check out this guy.
Hey, the boundary.
Emily.
What's now matching top and bottom?
The cosine x minus
A factor that we can reduce. It's 0! No, it's not. When you reduce what's left.
It's spelled
1 over.
I-O-U.
Oh, I did it wrong way. Aww. Could do that and do that. Okay. Gracias.
You were done. Like you.
So question. Can I do old school, algebraic, simplifying, factoring, multiplying to trig stuff?
Stonks. Yep.
What about this one? Go. You hated it when the e's needed factoring. Can you do it now that the trig needs factoring? You hated it once there were quadratics with e's. Can you do quadratics with cosines? Maybe use the x in the table. Maybe use guess and check. Maybe use the quadratic formula? I mean, you could.
Burn the quadrant formula alive.
How bad I used to be. I didn't erase it.
trying to take my pressure. I only have two. And I have to hold on to both of them.
I have my 3 most commonly distracted people all in the same place.
Okay, so like.
Don't answer that. Okay, so.
I'm leaving that.
I mean, I am mistaken. So. See, there's twins, right?
Sorry, Ben.
So you're only expecting
Alex.
1.
Sorry, Ben. As well.
And then you get 2.
How is that a mistake? I thought that was the double blessing.
Makes
No, so
total
what's an
sense.
accident?
What?
You have a very pessimistic view in life.
Those are your hours. E-I-O-U-R.
I respectfully disagree. So does God. Alright, so. I'm right. In this case, I'm right. You should all admit that. Maybe not you, because you're going to be stubborn for everybody else. Why am I putting a negative 36 and a 5? With a 9 and with a 4?
For the third. Wait, my bad, I said.
That's funky.
Funky fresh.
Now we're in honors, so maybe. We're in honors, so maybe. If I put a 3 cosine x and a 3 cosine x, and I put a. Well, I guess that doesn't totally work, does it?
Wait.
But I could put a 2 cosine x, and it used to make a 6.
I got a quick question.
And if I put a 3 out here, I'm coming out, give me a second. If I'm putting a 3 out here, which will make a 9, positive 9, and a 2 in here, which will make a 4, a negative 4, maybe some of you can start shortcutting your factoring. But the rest of you.
It's not even funny. I'm so confused. I need the extra long version.
One day I will have the brain.
Apparently, the smartest person is Roy than Caitlin.
Caitlin, Cassie,
And Cassie. And everyone else. And everyone else.
Hey, look,
except
guys,
for
it's
me.
right there.
Wait, what?
wait. But what if?
But everybody else. The good old fashioned.
I'm lost. Good old fashioned.
Good old fashioned way. You're at the top.
Group it.
How?
What's in common? A 3 cosine x. What's in common? A negative 2. What's left over? A 2 cosine x plus 3. You can do grouping too. You'll get there.
You'll get there.
We've reviewed factoring. Aw, come on. You just have cosines in there instead.
Wait, can we do the same thing we did with the E thingies and replace them with like U's?
Oh, yeah. Is that what you guys just don't like the cosine being in there?
I
Okay,
think-
sorry. I did use here.
So this would be like modified X method? Okay. So we just like skipped over the steps.
I think I'm dying.
Yes.
But technically,
What?
using the information is.
Oh.
And skipping straight to
I went to that.
first and outer and inner and left.
Did we
Yeah, that
get?
was yesterday. Yeah.
Oh, that was it? Oh,
You should take that.
Thank you, Steve. I appreciate it. No, I meant like.
Only
It's
G.
okay, it's okay, it's okay, it's okay. I'm just giving you a hard time because I know you can take it and that you somewhat appreciate it. Here you go. Here you go.
Oh, okay. Now see, my small brain's fine.
Pull out a 3, you pull out a negative 2, and then what's in common? Oh, I have to make more space.
Oh, wait.
Sorry, I've solved it too many ways, and so now it's just getting all.
How are we on this class?
Because we think.
I'm dragging down the entire. Because we think.
How's it done? I was looking for a
Again, how am I in honor?
Okay.
Think intellectually.
Now do you see it?
Yes, I do actually. Because we think, therefore we are in honors. But that should be our sweatshirt. We
Why are we
think.
in 5.1 instead of 6.1?
See, that should be-
Because of this natural disaster.
That should be our sweatshirt, Miss C. It's just we think.
Oh, I'm on it. I would buy that.
Yes, Caitlin.
I think a good way of actually doing it to somewhat describe it is, we think, therefore we talk.
We think, therefore we're in honors.
We talk and hopefully we think.
We think, therefore we get an extra GPA point.
We shall. Still, it's that thinking thinking part, though. Okay, so,
I don't really think. I'm just here.
ready, set! Are the directions the exact same? You can't really see them. Factor and simplify. No. Can you tell why?
With identity.
Are there any, no. Why isn't the word factor there? There's nothing in common.
Oh.
You see it?
Wait, we can make.
If there's something in common, or if it's a quadratic, we can factor it. Or if it's, AJ, right, a difference in squares, which is still a quadratic, that's possible to be factored. If there's a GCF, or if it's a difference of squares, or if it's a quadratic, factoring is a valid. Oh, this one didn't say simplify. How come? There was nothing else to do. Factor it. I'm like, okay.
Oh, no.
Are there any squares? No.
Why is there a B thing? It's so confusing. I can't write it down.
It's like beta.
What does B mean?
Beta. Remember the Greek song? We can pull it up. No, we're still
Yeah.
Alpha, beta, beta, beta.
Alpha, beta, gamma, delta, epsilon.
It sounds like
Oh, I wrote it down.
I'll make my kid.
That was actually in order.
Okay. No, you can repeat first.
Eta, zeta, theta.
I think my child's
Now you're making up things. Okay, so you can't factor, but why is it saying still to simplify?
Oh,
How can you make this simpler?
Sigma.
Ah, tangent can become good. Ella what? Ella's thinking.
Yes, that's exactly what I did.
Someone's thinking.
Okay, stop. No more quoting the Greek alphabet. Good job, but let's focus on the task at hand.
Oh yeah, there's
Okay.
a pi.
Yeah, shh. Now what?
so it's science.
Sine squared.
Oh, gee. No, I'm talking about the letters.
When you talk about letters, not a universe.
Still simplify. She sees it. Do you? Pause. I'm not going to have her say anything else. I'm going to see if you guys can get to the final answer. Go.
Wait.
Ow.
I'm selecting.
They're fractions. You're trying to put them together. Hopefully you're thinking of good old-fashioned. Two fractions to come together need to have common.
Denominators.
You can work forwards or you can use work backwards on this one because I gave you the answer. I guess if it was an odd, you could try to do that in homework too. If there were any equals like section 4.3, you wouldn't have to be doing this because you would see the other side.
No.
What is he?
It's just seeking for the answer.
Oh, maybe I guess.
Did you not hear me say that's the answer? Trying to get to it.
1 over cosine. So wait for a moment.
Did you get there?
No.
What do you mean you didn't get there? I just heard you say it.
Wait. See, all I said is secant is 1 over cosine.
Oh,
yeah.
you got
All I
there.
said.
Alex working backwards. Alex, because he's saying, I know what secant is. I wonder if I can get there. Has anybody gotten there yet?
No.
I'm just not. I don't just don't know what to do with the thing. Like, okay, we gotta come to numbers. I'm like,
Oh wait, yeah, I did it.
You guys told me common denominator.
wait, that's what I did. Why am I so lost?
I found this right.
Because, no, it looks totally different until an identity makes it possible.
Okay, I got it.
Wait, did everybody just call me stupid?
It's going to look like magic until an identity makes it. Dun, 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 dun. Do you know your Pythagoreans? What's sine squared of anything plus cosine squared of anything?
Wait.
Or okay,
Why do we use so many different Greek letters for the same thing?
I'm gonna use English letters like
I
A,
mean, to
B,
be
C,
honest,
D.
we pretty much use beta,
You're
alpha,
looking at the
and beta.
alphabet.
So,
Okay, boomer.
So this is unnecessary.
Oh, I got it.
So
Okay,
what was
let's
the point
go.
of writing down the
Greek letters show up in lots of different
What chart?
physics, math applications because you have many different variables. And there are some, like X is used so much that sometimes X and Y are actual like measurements, whereas the Greek letters can be things like density, or they can be things like volume. or
density
can be-
equals D over.
Density equals
M
M over B.
M
boomer.
over E.
And the Greek
True, but D for density, the Greek letters end up starting to take the place of some of these old-fashioned letters, so that way whenever you see it, it makes it stand apart from like a normal. Like pi. It's like, oh, I know that. but that's like a constant. You also have letters standing for quantities. Wait, hold on. Sorry, I didn't mean to lose anyone. I just was having fun, and I mean, I saw it, but common denominators. Math. I was getting it to be put together as a fraction, hoping that something would show up that's an identity, hoping that would help me get to something much simpler than it was to begin with. Now, some of you might be like, it's not simpler.
Okay, that's cute.
Focus. Shh.
Let's see the.
Stop. What if I was to do something like solve? Look at it. I'm curious. Just not right this second. It's impossible here because to solve, we always get this equal to 0 and we factor. But what did we just say we can't do?
Factor.
So there's no way to solve it?
No.
It's not a good old-fashioned polynomial. I can't just factor to get to where I want to go. But what can I do? Can I do this? Because then I would know this, which would lead me to this, which points me to a unit circle location that says, oh yeah, cosine can be 1/2. 1, 2, 3, 3, 2, 1. That happens at pi over 3s in appropriate quadrants. I know the answer because I put in the work to simplify it. Does that make sense? What have I just shown you? Section 5.3. This is a foundation that we're going to be practicing in 5.1 and 5.2 to be able to do 5.3 because 5.3 says solve and we can't solve it until we have a strategy to simplify it. But this is section 5.3. So, what do you guys think the directions are here? Factor. Simplify. Maybe. Because sometimes it does. No, where's my marker in my pocket? Sometimes it does give you a few hints. And Emily can see it. It's going to tell you exactly how to simplify. Get a common denominator. Now guys, 5.1 is building the foundation because 5.1 in the directions is saying, hey, hint, 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 try this. Hey, hint, 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 try this. Hey, just simplify, which means it's probably not factoring or common denominators. Just plug in stuff and see what happens. It's giving you hints in the directions as to how you can change it. 5.2 says, nah, no more hints. Just use all the skills in 5.1 to take this random equal equation, this random like section 4.3. Here's one side, here's the other side, and make it work. 5.2 is going to look weird because it's like, it gave me the answer. Well, it gave you what it could become, but do you know how to get there on your own? And then 5.3 says, hey, here are weird equations. You've got to make one side simpler to solve. So, common denominators. What would you do if you had a good old-fashioned denominator where they don't match?
Each other.
Yeah, this one times him, 3 over 3. This one times him, 2 over 2. So what do you do with trig?
Just freaking FOIL.
Why is Alex saying FOIL? Because they're both binomials.
Yes, I did something
Do you
right.
see it? It's just like the numbers. It just looks a little hard. Now pause. It's about to get super dangerous if you don't realize that all of these quantities are grouped, right? I'm saying quantities. It's a snazzy math way of talking about grouped expressions. Why am I saying that? Because Alex's use of FOIL was very important. I mean, could I technically just write them next to each other?
Yes.
Yeah. But remember, our big ultimate goal isn't just to rewrite it, but it's also not just to bring these two fractions together, but to also simplify. Here's another reason that these parentheses are really important. Why am I writing negative secant of x minus 1? I gotta distribute my negative. These numerators aren't being multiplied. The bottoms are being multiplied. The top is this times 1 minus this times 1. There's a subtraction that needs to go to both. Wait a minute, but secant minus secant, isn't that just 0? But come on, we know how to do negative numbers, right? -1 minus 1, left 1, left another 1, -1 plus a -1 is -2, not 0, right? We're good.
That's funny.
Our brains do funny things, I know. Why do I want to still follow Alex's advice of foiling?
So it could be a trinomial or a polynomial.
So it could be a polynomial.
Sorry.
Oh, this is gonna be a long one.
The difference of squares. Do you see it? KJ, do you see it? A minus b times a plus b. A squared minus b squared. Let's go in the other direction. Let's go in the other direction.
This is all base thing. Did you vibe check the air?
Oh, not by checking by.
Alex.
Are we so nice?
Okay, this is the one vibe checking on this.
Much a product of our culture.
I failed my vibe check.
Why is the final answer going to be -2 cotangent squared of x?
Because
It's a Pythagorean property. Isn't tangent squared of x plus 1 or 1 plus tangent squared of x secant squared?
Yeah.
Look at your rearrangement. Can't I say that secant squared take away 1? You see it?
secant equals 1 plus 10 though.
Yeah. So then subtract the 1 in that formula. Or look at your rearrangement. Look at right underneath the table. Didn't we write that tangent squared
Yeah.
equals secant squared minus 1?
In different.
The different arrangements one?
Oh
So,
yeah.
this is -2 over tangent squared of, and over tangent is cotangent squared of. If this was equal to a number, gross. If this is equal to a number, hey, divide by the -2 and go looking in the unit circle. Oh, after a plus or minus square root. So what about this one? I'm going to answer Priyanka's question as soon as I, wait. This one's weird. This is the one in homework that's going to feel way different. We're not just playing, doing math, like common denominators, or using properties, like Pythagorean. But this one is one of those, like, yes ma'am, yes sir. Like, okay, fine, we'll do whatever you tell us to. Substitute,
Okay.
plug it in,
Okay.
and simplify. Priyanka, what's that? As they
I
follow the instructions.
was just like, how can you make sure that you can stop what you said? Because, like,
On section 5.1, it's going to be frustrating because you don't know exactly what you're supposed to be doing. There's no clear
Oh,
ending.
sorry.
Yeah, sure.
So, could you have stopped at -2 over tangent squared of x?
yeah.
Yes.
Like, that's what I thought.
And it's okay, because technically, if that was equal to a number, I think I would rather solve that, because I know tangent better than I know cosine. So it's not necessarily bad. So when you, guys, here's a really good thing for homework. This one that you just did, that I pulled out of the homework exercise, is not literally the one selected for your homework, but the same grouping. Is it even or is it odd? Number 46. That one. So would have there been an answer in the back of the book?
No.
So you do the best you can. Come in tomorrow, see if your answer matches, and if it doesn't, see if you were on the right track and just didn't go as far. Because if you just didn't go as far, it's okay. Put a check on it. You were right, and then just put in parentheses tomorrow when we grade, I could have gone farther. The nice thing about section 5.2, but also the brutal thing about section 5.2, is they tell you exactly where you're supposed to get to. They give you an equation and say, guess what? This can become that, or this can become that. Show me how. In some ways it's nice because you know where you're going, but in some ways it's going to get frustrating because if you can't get there, you start making up some creative illegal math that might not actually be valid. Not. Has anybody plugged in?
I don't know where my homework file is.
Oh, that's true.
An issue.
But how are you supposed to do homework?
You're not supposed to do
Alec, you can always do it on a separate piece of paper and then tape or staple it. You can still take pictures of the separate piece of paper and submit it and have it be on time.
Wait, did you give that?
How did I? Oh,
That's
my
why.
TAs didn't grade it.
So no homework,
No, it needs to be due tomorrow.
party.
That's what they do.
Oh, you can still submit it on Google Classroom. That's the joy of pre-calculus being online. Now, grading it will be hard. Oh, but wait! I put all my videos online. Ugh, my TA didn't grade. You guys need to pick up your homework spirals before, or as you walk out the door. I guess I'll get the grades of the homework later. Pause! We're done! No! Why not pull out a 9? We're done! No! Why not make it sign squared? We're done! No, now it's legal without killing puppies to say, oh, hey look. Dun, 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 dun. You can ponder why that was a value. Bye. Bye.
Let me nab my homework.
Sorry. Didn't realize my TAs didn't grade. So thank you for having